this is the second video in the Mixtures and Alligation series. So in the first video, we saw what is this mixture and alligation topic all about, and what is the alligation formula, what is the basis of the alligation formula, the weighted average. Okay, so we saw all that, the connection between all that. Now let's proceed to slightly more difficult questions. So here we have a question, that is, how much water should be added to 60 liters of milk at 1.5 liters for rupees 20 so as to have a mixture worth rupees 10 and 2 by 3 per liter? Okay, so this is the question. Now here we have to get an average. Again, if you remember from the last video, we are working with averages. Okay, and averages could be anything. It can be the cost price, it can be percentage, it can be percentage concentration of the solution, right? So here in this situation, what is the average that we'll take? So we are talking about the cost here. So let's take the average cost price, right? So cost price is given here, 1.5 liter, the cost is rupees 20. So this is not the average cost price. This is the cost price of 1.5 liters. So first of all, our first step is to find the average cost price, right? So what is the average cost price of milk? It is 40 by 3. How did we get this 40 by 3? We have just divided it, right? We are trying to find it for 1 liter of milk. Find the cost for 1 liter of milk. And cost of water. Now he's adding water to it. We are considering the cost of water as 0 because it doesn't cost him anything to add water to the milk, right? So cost of water is considered as 0. So on one side you have milk and on the other side you have water, and we are taking the average cost price, right? So when you mix it, the mixture, what is the cost price of the mixture? It is 10 and 2 by 3 per liter. So let's look at how to represent it diagrammatically, if you remember the diagrammatic representation. So we have milk on one side and we have water on the other side, and the mixture, it is 32 by 3. The cost price is 32 by 3. How did we get 32 by 3? 10 and 2 by 3, which I have made it into 32 by 3. Now we have to subtract it, A2 minus A. So what do we get? 32 by 3 on one side and on the other side 8 by 3, right? Which is 40 by 3 minus 32 by 3. So we get 8 by 3 on the other side, right? So we have to find out how much water has to be added, right? So remember, what is the ratio we get? Whatever average we work with, the final ratio that we get is that is 32 by 3 by 8 by 3. What ratio is that? That is the ratio of the quantities of the two varieties mixed. So here we have the quantity of milk by quantity of water is equal to 32 by 3 by 8 by 3, right? So if we do that, what do we get? We have the quantity of milk with us, that is 60 liters. We are required to find how much water we need to mix so that we get this ratio. So let's take a look at this one. 32 by 3 by 8 by 3 is equal to 4:1, okay, and that is equal to 60 by x, and when we do that we get x is equal to 50, right? Remember, this ratio is the ratio of quantities, always, never forget that. The next one, in a mixture of milk and water, a different kind of question. Again, we are using alligation, weighted average, everything the same way, diagrammatic representation, right? But slight difference. It can be a little tricky, confusing when you read the question. So in a mixture of milk and water, there is only 26% water. So you have mixture of milk and water on one side, and they're telling us after replacing the mixture with 7 liters of pure milk, the percentage of milk in the mixture becomes 76%. So let's break down the question and try to understand what this is about, right? So we have milk and water. There is a mixture of milk and water. What are you adding to this mixture? We are adding milk to it. So it has been put in a certain way. You have to extract the information from that, right? So the mixture is replaced with pure milk. That means you're adding pure milk to it, right? And how much are you adding? You're adding 7 liters of pure milk. Now, what does this statement exactly mean? After replacing the mixture with 7 liters of pure milk, what does it exactly mean? It means that you're taking out 7 liters of the mixture and then adding pure milk to it, right? So, we have taken out 7 liters from this mixture. Okay, maybe it was X liters before. Now we are taking out 7 liters, right? So initially the mixture was X liters. Now it has become X minus 7 liters. And you are adding 7 liters of milk to it, right? So your N1 is X minus 7. Quantity of the mixture right now is X minus 7, which you are mixing with the other liquid, which is milk. Okay, 7 liters of milk, right, which becomes your N2. Okay, so right now your two things are, on one side you have milk and water mixture, on the other side you have pure milk, right? So here you have you're going to take the percentage of milk. Okay, in the mixture of milk and water, what is the percentage of milk? In the question you have been given the percentage of water, so you can easily find the percentage of milk. It is 74%. And what about the other side? You're adding milk to it, that is completely milk, which is 100% milk, right? So let's take a look at the working here. So you have 100 on the other side, and when you mix it, the mixture becomes 76%. Okay, 76% milk you have in this mixture. So again we do the subtraction, we get 24, and on the other side it is 2, right? Now what is your next step? N1 by N2, right? 24 by 2 is equal to N1 by N2. And you know what is N1? N1 is X minus 7 and N2 is 7, and 24 by 2 will be equal to N1 by N2. So take a look at this one. N1 by N2 is equal to 24 by 2, right? So this is how it has to be done. So you get the value of X. Your question is, what is the quantity of mixture? What was the quantity of mixture? Okay, so it was 91 liters, from which 7 liters was removed. Okay, the next question. So yet another question which we have to do very, very carefully, right? So here again your average is the cost price, right? So you have 9 rupees per kg on one side, on one variety is 9 rupees per kg, and the other variety is 7 rupees per kg, and we are talking about sugar. Okay, 2 varieties of sugar, and the first variety is being mixed with the second variety. The quantity of the second variety is given, right, and you're required to find the quantity of the first variety, right? So the first thing you have to understand is, what after mixing it, they are telling it is being sold at rupees 9.24 per kg. Would you put 9.24 here in the middle? After mixing it, it is being sold for 9.24 per kg. It is an average that is given, per kg price is given, but it is not 9.24. First of all, why it is not 9.24? See, when you're working with an average, it has to be the same throughout. It has to be uniform throughout. If you're working with the cost price, work with cost price everywhere. You cannot have cost price at one place and then selling price at another place. You cannot have percentage milk on one side and then percentage water on the other side, right? So you have to use the same thing uniformly throughout. So we are working with cost price as the average, but we have been given the selling price. Now by mistake, even if you've put 9.24, please make a check. This average cannot be greater than both these. It should lie between A1 and A2. A will lie between A1 and A2 because A is the average of A1 and A2, right? So it can never be more than this and this. Okay, so 9.24 cannot be put here, right? Because it is not the cost price, it is the selling price. So what is our next step? We have to find the cost price. So we have some data given here, that is 10%, that is the profit percent, and this is the selling price. So you have to recollect the formula for profit percent. What is the profit percent formula? Selling price minus cost price by cost price into 100 is equal to 10. Okay, so your cost price, the selling price is given, which is 9.24. If you substitute it here, your profit percent is also given. So the only unknown thing here is the cost price. So we need the cost price. Find it out. You get it as 8.4. Right? So we have 8.4 here. Okay. And then the same procedure. So now we have got the required things. Continue the same way. So we need to get the ratio, right? So on one side you will have 1.4, on the other side you'll have 6. Right, and the ratio 1.4 by 0.6 will be equal to N1 by N2. Right, by now you might be getting the hang of it, how to do it. This ratio that you get finally is always equal to N1 by N2, ratio of the quantities. So we are required to find N1 here. Let's see what we get. N1 by N2 is equal to 1.4 by 0.6, which is equal to 7 by 3, and 7 by 3 is equal to X by 27, N1 by N2. So your X is 63. Okay. So here we have another kind of question. We are working with ratios here for the first time. I mean, we didn't have questions where we have worked with ratio. We have worked with percentages, right? We have worked with cost price. Now let's see how we work with ratios here. So we have two vessels. Okay, on both sides we have a mixture of spirit and water, right? Now the ratio is given 5:2, 7:6. So as I've told you, we will work with one average. We'll work with one particular thing. We cannot work with both spirit and water at the same time, right? Let us work with one particular thing, because then even if we make mistakes, it's easy to rectify it. So I will take the spirit. Okay, I'm going to work with the spirit part of it, right? So if the ratio of spirit and water is 5:2, then the fraction of spirit in the first solution is 5/7. Okay, and the fraction of spirit in the second mixture would be 7/13. How did I get this? 5:2 is the ratio. So 5/5 plus 2 will give me the fraction of spirit. So that is 5/7, and on the other side it is 7/13. So finally when you mix it, they are telling us the ratio of spirit and water is 8:5. That means the fraction is 8/13. Now we proceed the same way. A2 minus A by A minus A1. Here we are required to find the ratio. That's all. You find the ratio and you're done. So on one side you get 1/13. On the other side you get 9/91. It's just subtraction. Again, A2 minus A and A minus A1. So what will be the ratio when you do this? You get 7/9. Okay, so there's not much to it. It's easy only. Only thing is we are working with ratios here, and this is how you can work with ratios, right? The next question. Okay, so here we have a question where no data is given at all. The only thing that is given is gain percentage, 16 and 2/3%. And one more detail that is given is you're selling the mixture at cost price. Okay, so how can we do this? Let us assume the cost price then, because nothing is given. So let us assume the cost price. So let us assume that the cost price of 1 liter of milk is 1 rupee, and it is given that the mixture is being sold at the cost price. Now this is what he claims, right? He's mixing it with water, but he's selling the 1 liter of milk also at 1 rupee, right? At the cost price. But what we have to understand is his cost price for 1 liter of milk is not 1 rupee, because he has mixed water with it now, right? And without any extra cost, he has mixed water with it. So for more than 1 liter of milk, now the cost is 1 rupee. So what will be the cost price of 1 liter of milk? I hope you have understood this data. He has adulterated the milk with water. Okay, so his cost price is no longer this 1 rupee that he claims, right? It is less than 1 rupee. So that we have to find out how much is his real cost price, actual cost price, so that he gets a gain of 16.2/3%. According to his claim, the selling price of 1 liter of milk is 1 rupee. So now we can apply it in the profit percent formula, selling price minus cost price by cost price into 100, right? So you put it in this formula, the selling price is 1, right? And you find the cost price. So I get the cost price as 6/7, right? So on one side I have milk, okay, cost price of milk. Now 1 liter, on one side I have the milk and on the other side I have water. I've got the cost price, it is 6/7 only, right? Now it is 6/7 on one side, and on the other side you have water, which is 0, okay? And when you mix this, what is the selling price? Let's see. After mixing, so originally what was the cost price of water? It was 0, and cost price of milk was 1. But when you mixed water with it, what happened to the cost price? It became 6/7. Now let us subtract it, right? As usual, A2 minus A and A minus A1, and then finding the ratio. So here again we have to find the ratio. Finding is not the problem. It is to figure out what is there over here and what is there over here and what are the averages we have to work with, right? Once you figure that out, you can do it just in under a minute, this problem, if you're using the alligation formula, right? So the answer is 1:6. Ratio is 1/6. I hope you understood this. We have to find the cost price after mixing it, because after mixing, the cost price of 1 liter is no longer 1 rupee, right? It'll be lesser. It is 6/7, right? So that is what I have represented in the diagram, right? The next one. Okay, so here a little complicated. Some things are happening here. I mean, a little tricky here, but not difficult. Yes. So here we have some, it is happening in 2 stages. Whatever is happening here, the mixing is happening in 2 stages, right? So we have a mixture of 35 liters, right? The ratio in which it is a mixture of petrol and kerosene, and the ratio is 4:1. Okay, now what is being done at the first stage? First stage, 7 liters of kerosene is added to the mixture. Okay, and the ratio of petrol to kerosene changes to the new ratio. Let's find out what the new ratio is. So it is 35 liters totally, which is divided in the ratio 4:1. Okay, petrol is 4 parts and kerosene is 1 part. So what is the quantity of petrol in the mixture? It is 28 liters, and quantity of kerosene in the mixture is 7 liters, right? You can use ratio and proportion to find it. Yes, so it is 28 liters. Now what happens? It is kerosene is being added to it. Okay, so kerosene is being added and this becomes 14 liters now, right? The kerosene, new quantity of kerosene is 14. And what is the new ratio? It is 2:1. So this is what they're talking about. The new ratio is what? 2:1, right? So you have 2 parts of petrol and 1 part of kerosene. So right now, what is the fraction of petrol? Now I'm going to work with the fraction of petrol. Now we are going to the second stage. That is where I'm going to use alligation, right? So in the second stage, what happens? Right now this mixture is 2:1, right? So what is the fraction of petrol? It is 2/3. And you are adding petrol to it, complete 100% petrol. What is the fraction of petrol? It'll be 1. Right? You represent the 100% as 100/100, right? So the fraction of petrol here is 1. And when you mix it, you should go back to the old ratio, which is 4:1. So that is the condition given to us, right? So what will be the fraction of petrol? If you go back to the old ratio, it will be 4/5. So the meaning is the new ratio, when mixed with this petrol, should give me the old ratio. So that is what is represented diagrammatically, right? 2/3 on one side, mixture of petrol and kerosene. This one is complete petrol, right? You mix it and you get a mixture with the old ratio, 4:1. So the fraction of petrol there is 4/5. Again, you subtract it, A2 minus A, you get 1 by 5. A minus A1, you get 2 by 15. Right? So you are supposed to find the how much petrol should be added. Okay, so how much is the mixture now? It is 35 liters. It was 35 liters. Okay. When 7 liters in the first stage, you remember the 7 liters of kerosene, when it was added, how much did it become? It became 42, right? So it is 42 by, okay, now this mixture, when it comes to this ratio 2:1, the total quantity N1 should be 42, okay, and this 42 is being mixed with this petrol, right? How much petrol? We do not know. So 42 by X should be equal to this ratio. Let's take a look at this one. The working N1 by N2 is equal to 42. I hope you understood how we got 42. It is not 35 liters, right? Kerosene was added. So right now our total quantity is 42. So that is what I have put here. 3 by 2 is equal to 42 by X, right? So you get the quantity of petrol that was to be added, right? N1 by N2. Next question. So here again a little, more working is there. It's not difficult, just the number of steps are more. Let's take a look at this. So a girl has a 1 liter solution that contains orange juice and water in the ratio 3:1. So we are dealing with a mixture of orange juice and water. She adds 250 ml of 3:2 solution of orange juice and water to it. Okay. So on one side we have orange juice and water, mixture of orange juice and water. On the other side we have again a mixture of orange juice and water, but the quantity is lesser, right? On one side we have 1 liter, so that will be our N1. Okay, N1 will be 1 liter. Okay, and on the other side N2 will be 250 ml, right? So I'm working with the fraction. So before that, a few things have to be done. First solution, the ratio is 3:1, right? And total overall quantity of the solution is 1000. So how much orange juice is there? 750 ml, right? And 3/4 of 1000, you know how to work with ratio and proportion, right? You should know. And then therefore the quantity of water is 250. In the second solution, similarly, 3:2 is the ratio. So working with that ratio, we get the quantity of orange juice is 150 ml and quantity of water is 100 ml, right? So the total orange juice now in the mixture, that is once you mix both these things, the first solution and the second solution, the total orange juice in the mixture is 900 ml. Okay, now another thing is we have been given N1 and N2. So the ratio we already know it is 4:1, right? So here the quantity that is missing is this average, overall average. We have to find it, we must find this to find out how much juice is she left with. For that we need to find this, right? So that is what we'll do. What are we given? We have been given, I'm going to work with the fraction of orange juice, right? So in the first solution, it's 3/4. In the second solution, it's 3/5. In the final solution, what is it? This I don't know. Okay, I will try to find it out. And I have been given the ratio. So I can do this 4:1. Okay. So A2 minus A, this time A is missing. So we have to find the A, but the formula, alligation formula is the same, right? So when we do this, that is A2 minus A by A minus A1 is equal to N1 by N2, I get the value of X. So 18/25 is the fraction of orange juice. And then if that is the fraction of orange juice, from how much is she taking to make the complete juice? She uses 250 ml of the combined mixture. Okay, so in 250 ml, how much is the orange juice? You know that the fraction is 18/25, right? 18 by 25 is the fraction of orange juice in the mixture. In 25 parts, 18 parts is orange juice and 17 parts will be water. Whatever part of the, how much ever quantity of the orange juice you take, 18 parts will be orange juice and 17 parts will be water. That is what it means, this 18 by 25. So if you take 18 by 25 of that 250 ml, how much orange juice is there? 180 ml. And totally how much orange juice was there? 750 plus 150, 900 ml was there, right? So from that you have to take off this 180 ml. I hope you understood this. There are a lot of steps and you have to connect all this, right? You have to connect the normal calculation with this alligation thing that we have applied, right? Once more I'll explain to you. So in this 1 liter solution, we have 3:1. The ratio is 3:1. From this, I find the quantity of orange juice, right? And there is quantity of water. Forget about the water there. Right now, let's concentrate on this orange juice, right? So in the first solution, quantity of orange juice is 750. In the second solution, it is 150. Therefore, in the mixture, it will be 750 plus 150. That is 900 ml of orange juice is there in the mixture, okay? But she is taking only 250 ml from the final mixture, right? And in that 250 ml, how much orange juice would be there? That you have to subtract from this 900 ml overall orange juice. That is what they have asked us. Okay, so we have seen quite a few questions. Each one of them were of different kind and slightly tricky, right? So we'll continue with mixtures and alligation in the next video. Thank you.